All right, so in this video, I'm wanting to cover the properties of logarithms. A while back, probably in pre-algebra, you talked about the properties of exponents. So when you're multiplying things with like bases, the rule is you get to add up those exponents, all right? And if it's division, you get to subtract the exponents. If you have a power to another power, you get to multiply the exponents. So each of these properties has a kind of a similar feel or a mirror property in the world of logarithms. Okay, so the one for multiplication and addition would go something like this. If you have the log of any base, if you have the log of two numbers being multiplied, all right, you could rewrite that as the sum of the logs of each factor, I guess. So the log of a product ends up equaling the sum of the logs of each of the factors. All right, so if you have a product, you could separate that into a sum. Right? If you have the log of a quotient, division, you can rewrite this in terms of a subtraction instead of an addition. All right, it's just equal to the log of x minus the log of y. And then the last one is if you have the log of something raised to some power. Okay. If you have the log of something raised to some power, you can rewrite that as whatever that exponent is, y, times the log of your base, times the log of x. All right. And this is just because you're basically doing repeated multiplication. All right. And since repeated multiplication, or since multiplication gets rewritten as a sum, and you're repeating that sum y times, that's why you get y times the log of that thing. All right. So these are our three properties of logarithms. You'll want to memorize them, I suppose. But the log of a product you can rewrite as the sum, and well, there they are. There's other ones. All right. I'm going to use this one to evaluate log base 2 of 1/16. All right. We did some of these the other day. It's just 2 to some power is equal to 1/16. And I believe the answer is -4 is what it comes out to. So this should equal -4. All right. I'm going to rewrite this using this logarithm rule. So I could rewrite it as log base 2 of 1 minus log base 2 of 16. All right, using that subtraction rule. And then log base 2 of 1, that's just equal to 0, because 2 to the 0 gives you 1. Minus, and then log base 2 of 16, that's equal to 4, because 2 to the 4th gives you 16. And you see when you subtract them, you get -4. Okay. So you can use it to sometimes simplify, evaluating logarithms. It can be useful in that scenario. What we're going to be using them primarily for is to expand and condense. All right, so what I'm going to do here is I want to expand log of x to the 4th times y to the 6th. Okay, I want to expand this all the way out using those properties of logarithms. Okay, so because I have the log of a product, I'm going to rewrite that as a sum. So this is going to be the log of x to the 4th plus the log of y to the 6th. All right, that's just using that multiplication rule. And then because we have an exponent, which is repeated multiplication, I'm going to use that power rule here. All right, I'm just going to take my exponent and it gets put out front as a multiplication. So this one is going to equal 4 times the log of x plus 6 times the log of y. All right. I've expanded my logarithm out. All right. Instead of having just one logarithm, now I've got two. Okay. Do that for a couple more of these. Let's do the log of 4x divided by y. Okay. So the first thing I'm going to do is I'm going to separate them using the subtraction rule. This is going to be equal to the log of 4x minus the log of y. All right. Separating the division into a subtraction statement. And then this piece can be separated again because you've got 4 multiplied by x. Right? Since it's a multiplication, it'll separate into 2 additions. So it's going to be log 4 plus log x minus log y. All right, and that's it. All right, I took all 3 of my pieces, these are actually factors, and rewrote them in terms of sums and differences. So I do want to mention there is no such rule for the log of a sum. So if you're given something like log of x plus y, there's no way to rewrite that. There's nothing that we can do to expand that or condense it. It's simply just log of x plus y. There's nothing you can do to simplify it. All right, got one more here, one more example. Log of 7 root 2x. Okay. The first thing I'm going to do is I can separate the 7 from the square root part because they're connected by multiplication. All right, that's 7 times the root of 2x. This is going to be log of 7 plus the log of this piece. All right, now the square root, that's the same as 2x to the 1/2 power. So I'm going to rewrite that as log of 2x to the 1/2 power. Okay. And now what I get to do is I get to use this exponent rule. I get to bring that exponent off to the left-hand side of the log. So this is going to be log of 7 plus 1/2 the log of 2x. All right. And then, of course, you get to separate this into 2. It would be the sum, I guess. It'd be log 2 plus log x. All right. So it's going to be log 7 plus. Now this 1/2 is going to get distributed because this 1/2 applies to both of these. So it's going to be 1/2 log 2 plus 1/2 log x. Right. So that 1/2 applied to the 2 and to the x, so it's going to apply to both pieces down here as well. Right. I guess you could have just went straight from here to there. Anyway, that's it for this one. In the next video, we'll talk about condensing, all right, instead of expanding.